All right, thank you. All right, so we got 1.5 angles in their measures. It's not too bad today. Pretty smooth lesson for you. First of all, what is an angle? Everybody knows what an angle is, but what is it actually made of? Rays, right? So you could probably say points too, but it's also rays, right? If I have a ray going this way and a ray going that way, what do I have? I have an angle, right? And what's one thing that's important, when these two rays came together, what happened? They had a common point. So this ray and this ray came together with a common point, common endpoint, which has a name. What's that name called? Vertex. Very good. What kind of angle is this? What kind of angle is this? This is acute. 90 degrees, which means it's right angle when we classify them. And if it goes greater than 90 and less than 180, it's obtuse. What if I go all the way to make opposite rays? Say it again, Jacob. Very good. That's a straight angle.
Is that 180?
Exactly 180 degrees. Exactly 90. Between 0 and 90, between 90 and 180. So I covered two things. An angle is made up of two rays with a common endpoint called the vertex, and we just classified the four types of angles. That's a two for us, a little BOGO right there. Sometimes I talk to the screen. Oh, we've been naming segments, we've been naming rays, segments, planes, naming angles, also have its own symbol. What's the symbol for ray? I'm sorry, symbol for angle. Literally an angle, right? Try not to make a greater than sign, try to make it down and then flat. Sometimes when I do it, or you might even see it, they'll put like a little arc in there. So this is the symbol for angle. Okay, now how do you name it? 3 letters. The key is the vertex has to go in the middle. So this becomes angle CAB. Does order matter with an angle? No. Just like with segments and lines, it doesn't matter. So I can call it angle CAB or BAC. But A has to go in the middle. Look down here and you can see they've already done that for you. That's how you name an angle, with the symbol and then 3 letters. Now, there are some shortcuts, like there was with a line, remember? If you only have one angle here, which I do, does everybody see I only have one angle here? There's only one angle here, then why don't I just call it angle A? Could I do that?
Yeah.
I can. I can call it just angle A, and you see that right here.
What is the angle 1?
Now, not so much here, but sometimes, especially when the diagram gets a little bit more crazy, right? You might have a diagram like this that has 3 angles, right? There's 3 angles here. Everybody see the 3 angles?
Yes.
The 2 here and the surrounding one?
Yeah.
So they might put a 1 here and a 2 there. So when they do that, if they put a number there, you can't put it in there. If they put the number there, we can also call it angle 1. So 3 different ways to name an angle. The 3 letters is the safest, the vertex or the number that's in the little crack there. Now, let me show you something. Can I call this angle A? Can I call this angle A? Yes. Can I call this angle A?
No.
No, because there's 3 angles there. So I said there are some limitations. So this would not be angle A. I would have to call it angle CAB. Now, I could call this CAD, but why not just call it what?
Angle 1.
Angle 1. All right, here we go. Interior is like Sesame Street. Near, far. Interior, exterior. So this is an angle. All these points are what?
Interior.
On the interior. It's for a theorem later on. Common sense. Quick slide. There you go. Inside, outside. Here we go. This is the same question I just asked a minute ago. And what was that?
3.
It says how many different angles are here. I've already kind of done that. There are 3. So the answer to this is there are 3. I'm gonna do a little part. I'm gonna do a question number C in just a minute. What are the two ways to name angle 1?
MPN.
I could call it angle 1. That's the best way. But I could call it what?
MPN.
Angle MPN, comma.
Or NPN.
The order, right? It's the same one, right? It's not the different angles. It's just 2 different ways of naming it. I cannot call it.
Angle P.
See, that'd be a good head puzzle question, wouldn't it?
No.
I would pop. Yeah, I would. Except you gave me the answer too fast. I do that when I make a head puzzle video. I'll pause, and then I'll say
English
English.
P. That's an M at the right?
Yes, I could have definitely messed that up. Because I'm thinking about somebody else, not people. Now, my other question is, can we name the 3 angles? If I gave you that diagram and I said, name the 3 angles, what would you put first? Good. I would put angle MPQ. Get the hard one out of the way, right? And then no. Then what would I say next? No.
Or NPQ.
Remember,
MPM.
if they put a 1 there,
Oh, angle 1.
if they put the 1 there, call it angle 1, right?
Alright, angle 1.
I mean, you're not wrong. You could say angle MPN, but I'm going to call it angle 1. Then I'm going to call the other one what?
Angle 2.
Please know they could be replaced by the 3 letters, but when they put it there, shortcut. You guys like shortcuts?
I love short.
I like the hypotenuse.
I wish I was.
Yeah, Key and Peele, that's a good joke. I'll laugh when we get home.
And the guy.
Hey, anybody know what a protractor is? I said this joke 4 times, no one's laughed. I don't think they will either. What's a protractor? A really good tractor.
Yeah.
Yeah, it was bad. You won't even laugh. You laughed at that one?
We had so many opportunities today.
It's obviously if you're measuring angles, it's pretty simple as long as that first ray, that bottom ray is going to the 0, right? Does everybody see that passing to the 0? Now because the 0 is on the inside lane, I'm gonna travel along the what? The inside lane, so I get 30 degrees here and not what? 150. So how do I know whether to read the 30 or the 150? 2 methods. The method I just told you, you start wherever the 0 is. The other method is common sense. Is that an acute angle or an obtuse angle? It's acute, so it's definitely going to be the 30, not the 150. Sometimes that starting ray is here. Could the starting ray be over here?
Yes.
It can be. I have this slide here. You can't see it, but I can. Can you guys see what this angle is?
Yeah. 50.
Is it 120? Is it 115 or 65?
5.
Look at the difference, right? Look at my starting point. Where is it at? Whoa. Isn't that cool? Yeah, this thing rotates. So that's 0 degrees. The 0 degrees now is on the outside lane, isn't it?
Yeah.
So I'm going to go there at 65. Or common sense says what? Bless you. Now, will this get more difficult? How can I make it more difficult?
By adding another angle?
Yeah, okay, I like that. What if I take this nice cozy thing and I put it here? Ew.
Then we start at 20.
You start at 20.
So you
Okay, it can get
subtract.
even worse. It could go like there, and then I can put this one. I can put it way over here, way over there.
It's so.
What's the measure of that angle? Wait, don't say it out loud yet. What's the measure of that angle? Good time for an Ed puzzle question.
110.
What'd you do?
I subtracted.
You subtracted. Just like with a ruler, right?
Yes.
These are coordinates on the protractor like the coordinates on a ruler, so I can subtract the coordinates. But make sure that if I'm going to subtract, I got to use both tops or what? The either inside lane numbers or the outside lane. So I'm going to take 140 and subtract what? That's the safest way, right? Big number minus what? Just so if you look at the notes, I'm supposed to say what? Absolute value, but I avoid that by picking a bigger number. Because I could go on the inside lane too. Could I say 40 minus 150?
Yes.
Could I say 40 minus 150?
Yep.
As long as I absolute value, yes. What if you don't know how to subtract? Can you count?
Yeah.
10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. That works too. I'm not going to check your work, but you better know how to do this too because it could give you some weird ugly numbers too. Are we good?
Yes, sir.
All right. Remember that every angle has a 1-to-1 correspondence with the protractor, just like the ruler postulate says what? Every number has a 1-to-1 correspondence to the ruler. Rick the ruler. There's only 125. Whenever it's on 0, you don't have to show me that work. Okay? That's not necessary. This book is one of the few that does it. Have I already covered classifying angles? Yes. I did it in my intro, right? Angles that are less than 90, greater than 0 are called acute. Oh, they're so cute. And this one, make sure you don't assume that. Make sure you know it's the right angle. Otherwise, we can't assume it. It has to have a little corner in there. That's a right angle, exactly 90 degrees. And then we have obtuse, bigger than 90, less than 180. And a straight angle. I had a kid last period did not know what this was called.
It's a ray.
It's been rotated 180 degrees. It's a straight angle. Also looks like opposite rays too, doesn't it? Hey, what's up?
For these, I see for like these right here, it says M then angle C.
Okay, that's a great question. Thank you for saying that. That's like really good. It's a good time for the video too. Yeah, when I say name this angle, how would you name it? Angle C, right? Okay. Now, when I want to talk about the measure of the angle, I would put what? So if you see the measure of angle C here, they're asking, hey, I want the actual degree measure of the angle. Remember this before with a segment? If I put
Yeah.
AB congruent, you would put a segment, right?
Yeah.
But when I put AB, I was referring to what? The length, the measure, right? How long is AB? It's kind of like that here, right? Good question. Good question. Is it right? Does it look good? Got a little shout out. You're gonna be a star. You're gonna be a star. I didn't want to call you Sam's brother in the video, or I just did. This is the same kind of question. We're not going to do these because they're really easy. I'm going to pick a harder one from this diagram, and you're going to do it. Don't yell it out because they're going to be doing it on the Ed puzzle too. I want you to find the measure of the angle NQM. Please do that right now. Don't yell it out. Just write it down in your notes. You need to write the NQM because that's not there either. Good. Did everybody get what? Tell me what you got. I know. I gotta go. We gotta go. Somebody get it. What do you get? 120. Everybody get 120?
Yeah.
How'd you get 120? 135 minus 15 is 120. Good. Is everybody good? I don't want to sit there and have 5 minutes downtime. One more time. 135 minus 15. 120. And that's degrees, right? Okay, good. Thank you. Thank you for understanding. Okay, kind of like with segments, right? Segments can be congruent and angles can be congruent. What is your first name? First name? First name. Mateo. So you see here, same kind of thing, right? The angles are what? Congruent, but if they're congruent, then they are equal. When they are equal, we put the M. When we call them congruent, we use the name. That was going to come up, but it's a good question. Are we good? Yes. Now, how do you know? Well, we had tick marks with segments, right? What about angles? We have what? We have these little arcs, right? So we have one arc here, one arc there, they're congruent. And then we have what? Two arcs, therefore they are congruent. That's how we mark congruent angles. You see that a lot of times with isosceles triangles, right? They'll go like that. Those angles are congruent. Now what? They're all congruent. Now those two are, but that one's not. This is ridiculously absurd and insults your intelligence. Okay, this is the big one today. This is what I want to get to. Angle addition postulate. Hey, that looks familiar. Except we had the segment addition postulate. Remember that one? The pieces add up to be the whole thing. Same overall concept. Instead of the segments adding to the whole thing, now it's going to say what? The red angle plus the green angle. I feel like a little Dr. Seuss here. Equals to what? The blue angle. The sum of the pieces equals the whole thing. And then we're going to be doing problems like that. Okay? We good? Yeah. One more time. There's that word interior. Remember they said interior, exterior. So what it means is if I have an angle, right? If I have an angle and then I have a point inside and I draw that ray, then it divides these into the whole thing. Okay? Have a seat and take your notes out. Don't touch that stand, please.
To your desk, bro.
It's hard, bro.
Hey, I think you almost did the whole period. Good job. Not bad. I don't think I could have done that. All right, this is a good little question, little fun question. The question, I'm going to get to the end here because we're running out of time. What is the measure of that angle of a pizza? So I go to Costco and go, yeah, let me get one of them slices. Oh, they're so good too, right? What is that vertex? When I go take that first bite, what is the angle of the pizza?
It's like
Cute? No, it's 45.
Acute's a good general answer, but what is it exactly? Can you calculate it exactly? What is it here?
50.
What? 180. When I cut it in 4 pieces, what is it? 90. Then I cut that in half, what do I get? That's the common sense way, right? But technically, you know, what's the rotation of a circle? 360, right? So if I take the 360 and I divide it by how many slices I have, I would also get 45. I like common sense though, right? Watch how much faster common sense is. Don't yell it out, give me like 2-second pause. What if I had 16 slices? What would the measure of the angles be? Go ahead. You can say it now.
20.
What?
21?
So I heard it.
22 and a half?
22 and a half. Who said it? Somebody said it. Yeah, 22 and a half. Good.
21?
And here's the work right here. It's showing you that you would take 360 divided by 8. That's a cool little, whenever I can put pizza in a word problem, I'm excited about it. Okay, good news, last problem. So we finish this, we're done, okay?
Yes, sir.
Alright, so we're gonna use the angle addition postulate to solve this problem. The question says, it doesn't say solve for x, what does it say? Find the measures of the angle. So I'm gonna solve for x first, and then I'm gonna
Find man.
plug it in and find the angle. Now, a lot of times they might tell you what the outside angle here is. They kind of tell you indirectly, don't they? They say that's a right angle, which our interpretation is, okay, then it's 90. Which means the sum of the smaller angle plus what?
The bigger one.
The sum of the mid-size is going to equal mama bear, right? Or baby bear, mama bear equals papa bear. So, here we go. Are you ready? We're going to go 3x plus 5 plus 10x minus 6 equals, pause.
90.
Good. Perfect timing. And then we clean that up, solve for x. 10 and 3 is what, 13x? I'm combining the like terms on the left side.
-1.
Minus 1 equals 90. Add 1 to both sides. 13x equals 91. I would do some long division over here, or I've done this about 4 times now, and I do know that x equals 7. When I get a round number, I feel good. I get a whole number, I feel like I might have done it right. Feels like I'm done, but I'm not. Now I gotta plug that 7 in. Where? Into here, into there, and I get my 2 answers. Luckily, this slide, I left it, I didn't cover, usually I cover them up, right? I didn't cover it up, and it's showing you that one of the angle is 26. I covered that up too? Did I really?
It's on the next slide.
Try the next slide. Okay, now who's bad? Who's bad? Hey, thanks for coming. Great day. That was pretty good. How about a golf clap for you guys and for Mr. Fraser? Good job. Thank you. Pause. End it. When the bell rings, you go.